Welcome back to ArmanisMath. Today we're going to focus on the rational functions. All right. So I'm going to start with kind of a little warm-up here. And this one is going to be the quadratic. Okay, this is just a warm-up. So help me with the warm-up, okay? This is a warm-up for us today. I have this quadratic. This is the parent. Y equals x squared. Can somebody tell me what would happen if I have y equals x minus 2 squared plus 3? Can somebody tell me what happens, what kind of transformation is happening here? Am I moving up or down or left or right? What exactly is going on here with this function? Use your whiteboard, use your chat, use your live stream comments. You have multiple ways to reach me. And I see answers start to pour in, and I see here going up 3, that is very true, and to the right 2, that is very true. Good job, you guys. Whoever participated, that's good. You're moving to the right 2 because this is H and this is horizontal. With the X is always the opposite what you see here. If it's negative, you move to the right. If it's positive, you move to the left. This is the K term, or the vertical, and that's going to be up 3. So basically, instead of 0, 0, my point here being the vertex, or the focal point here, the vertex to me here, is going to be moved to the right to 1 and 2. Let's say this is 1 and this is 2, and up 1, 2, 3. So we moved from here to there using the transformation. This was a quick warm-up. I also want to put here something down that reminds you that there was an a, and then there was an x minus h squared plus the k. Do you guys remember that? It's called the vertex form of the parabola, the vertex form. Okay, this was a warm-up. I did this because we have a similar concept today, except the function we're going to talk about is called rational function. So in the rational function, you have this setup here. You basically have y equals 1 over x. This is the exact function. It's called 1 over x, or reciprocal function. Reciprocal function, or rational function, this one here. This is the parent. And when you graph the parent for this graph, for this function, let me graph the parent here. You'll find out there's something that is very interesting. Actually, I have to use a different color for the graphing. And the things that you're going to find out is this graph, when you actually graph it, it becomes like 2 curves. So it's not one curve connected, it's actually 2 curves that are disconnected. Okay? And the main point, the focal point I should say, or the main point is 0, 0. We're talking about the parent right now. This is the rational function. Rational. And it's graphed like this. Two separate curves that they do not touch. They wouldn't touch. I also want to mention something about these 2 curves, because the curves in rational function will come so close to this axis here, but never touch. For example, if this is a 1, and this is here a 1, like 1, 1, this point is 1, 1, and let's say this point is negative 1, negative 1. Hopefully you're taking notes here. The points, the closeness to the axis, how close this thing come to the axis, is going to be a little bit less than 1. If this is negative 1 here and negative 1 here, this would become like a this height is negative half, and this is going to be a negative quarter, and then a negative 1/16, and then a negative, and then you get the drift, okay? So you're going to be adding numbers to the bottom, which makes the fraction smaller, but will never make the fraction 0, meaning I'm not going to touch the x-axis. Same thing in this deal here. If this is a height of 1 at the top here, then if you do 2, it's going to be 1/2. If you do 3, it's 1/3. 4 is 1/4. 5 is 1/5, etc., etc., etc. You're going to find yourself heading towards the x-axis, but not touching it. So the not touching it concept in math, is referred to by a word, and the word is asymptotes. What? What did he just say? What did he just say? It's called asymptotes, and it's not a bad word. It's spelled like this. You have asymptote. The idea of asymptotes is basically lines that you do not cross. You're walking and then all of a sudden you have a freeway. Well, you can't walk across the freeway. You have to hop over, right? You're going to take the bridge, right, to hop over. And we talked about this idea when we talked about domain and range, if you guys remember at the very beginning of the year, domain and range. So asymptotes are invisible lines that you cannot cross. They come in handy here in this rational function because there will be 2 of them. What do I mean by that? Well, let me show you. If you were to graph this carefully and you make yourself a table, you will find yourself having 2 asymptotes. I'm going to put them here right in front of you. I'm going to put the one here. I can't cross this line. I cannot cross this line. It's actually on top of the y-axis. And this is actually has an equation. Every line has an equation. This one is x equals 0. Oh, Armania, I thought you said this is the y-axis. Yes, it's the y-axis, but the equation for the y-axis is x equals 0. Keep in mind also we have another asymptote for this rational function, another asymptote, which actually lies on top of the x-axis itself as well. On top of the x-axis, this guy is waiting here and says you can't touch him, sorry. And the equation for this line is y equals 0. Armani, I thought you said this is the x-axis. Yes, I said that. But the equation for the x-axis is y equals 0. Okay. So now I know I have 2 lines I cannot cross. One that is vertical at x equals 0, and one that is horizontal at y equals 0. So these 2 curves will not touch these 2 lines. They won't. No matter how big the number becomes. For example, what if you said, hey, what if I want to put 1 million? Okay, so y equals 1 over 1 million. 1, 2, 3, 4, 5, 6 zeros. Well, that's too small of a number. You're right, it is small of a number. So you come so close here, right? If you put 1 million here for y, for x, well, that's going to give you 1 over millionth, which is going to be pretty tiny. You're getting so close to the x-axis, but never touching. And that's, again, the idea of asymptotes. So you have basically 2 asymptotes for this rational function. At y equals 0, there is a horizontal asymptote. X equals 0, there is a vertical asymptote. If you want to write it down, horizontal asymptote, vertical asymptote. Okay? Okay, so a quick check for understanding here. How many asymptotes do we have for the rational functions? How many asymptotes do we have for the rational functions? Okay, multiple users are typing. Here we go. Kathleen, Shalom, and Devon, and Kennedy, and yep. Okay, so this is the graph of the parent function. This is the parent function. And by the way, if you don't feel good about this graph, like where did he come up with that? Well, if you have a function, you could make yourself a table. Don't forget that. Anytime you have a function, you could create a table. So I'm just going to put a table here for you. I'm going to put a short table here for you and put some points. That's why we got these here, 2 curves. What did he come up with these? Well, that's because I know the graph of this function. But if you don't, that's okay. Make yourself a table, x and y, and put some values. Here's a function here. y equals 1 over x. This is the function we have today. This is the parent rational function. So if I put, let's say I put for the denominator, that's when you guys should have an asymptote. So basically I'm just going to write a little bit slower here. Negative 2 is going to give me negative 1 over 2 negative half. If I put negative 1, I will get negative 1. If I put 1, I will get 1. If I put 0, I'm going to get something that I do not like, which is 1 over 0. Really sad face here. Really sad face. It's undefined value. And that's why you have this asymptote here. At 0, you have undefined. And if you put 0 for y, if you put 0 for y here, I'm going to do that at the bottom. So here's your function, y equals 1 over x. If you put 0 for y, so y becomes 0. Well, that's equals 1 over x. Cross multiply. That's going to give you 0, right? Because 0 times any number is 0, except itself. 0 equals 1. Is that a true statement? Is this a true statement? Does 0 equal 1? No, it doesn't. So if you put 0 for x, for y, you will get also 1 over 0, which is not good, not good. And that's why we said we have the idea of asymptotes to cover these 2 points here. 0 for x is going to give you undefined. 0 for y is going to give you also not a true statement, which is going to give you an asymptote at that location. That's why we have 2 asymptotes for this location here. Okay. This one here, we're going to actually look at the transformation now. So this was the parent function. Now we have a transformed, basically a transformed rational function. So I'm going to start with this color here. Y equals, I have a divided by ax minus h, horizontal, plus the k. As simple as that. So here's my new enhanced rational functions. This is the transformed function of this rational function here. A would be a factor that I would multiply by. It could be a fraction. It could be a whole number. And x minus h is always the same. So you are actually moving in opposite sign of this. And k is up and down. So for example, what if I gave you this one here? I'm going to say y equals 1 over x minus 4. Y equals 1 over x minus 4. And then plus 2. What could you guess about this just from looking at our quadratic function at the top in the warm-up as we had? What happens here? Do you guys remember? What happens here is you move, again, you're moving to the right. Well, you're moving this focal point here. You're going to have 2 asymptotes. Yep. But your center of your graph is shifted according to this here. I move up or down here. The k is going to move up. So I'm going to move up 2. Okay. And then at what point am I actually shifting? Well, instead of 0, 0 being the center, the focal point, you're actually going to move this guy to the right 4. So I have 1. Got 1. Let's say this is 1, 2, 3, 4. And then I have to move. I'm going to have to actually, let me make this a negative. I'm going to have to move down 2 units. So I'm going to just fix this one here. I have enough room down here. So I'm going to have to move down 2 units. That's the k term, down 2 units. So let me move down 2 units here. I've got 1 and 2. 1 and 2. So I'm down here. So my blob, my focal point, instead of 0, 0, it actually moved down to basically 4, negative 2. This became this point here. I will not also forget that I have asymptotes. Don't forget the asymptotes because they help you graph. So at the top of this, I have my asymptote, which actually goes through the h part. So I'm going to go through the 4, x equals 4. That's a vertical asymptote. And this is going to be at x equals 4. And the other guy is going to be exactly at -2. And I would go here and go to the -2 and also have a horizontal asymptote. At y equals -2. How did I get that? Well, I looked at here, and that gave me -2, by the way. Okay, how do you graph? Well, again, these are two curves that are separated by these lines, by the blue lines. And the curves would look like something like that. See this here? That's a curve. And another one that looks like this down here. This is a curve, actually. It's not a straight line. That's a curve like this. Okay, remember these lines will never cross. These lines will never cross the asymptotes in either direction. They'll never cross the asymptotes. Okay. Do I have any question on these graphs here? Any questions on these graphs? Now, again, if you don't think this is cutting it for you, this is not making it, it doesn't click, then because you have a function, make yourself a short table and graph. Obviously, you could use Desmos, but if you want to make it yourself, definitely you have the capacity because you have a function. If you have a function, you could make yourself a table and then come up with points. By the way, nobody has to give you points. You suggest points. Here's x and y. If I put let's say 4. Let's start with the negative actually. Let's start with the -1. If I put -1 for x, that's -1 minus 4, that's a -5. So basically you're saying -1/5, -1/5 minus 2. -1/5 minus 2 will it's like a 2 if 2 is 5/5, if 1 is 5/5 and 2 is 10, you're taking away 5 from them. 1/5, 1/5 I should say. So that's 9/5. Basically you have 9/5. So if I put -2 here for y, so y equals I've got 1/x minus 4 minus 2. If y is -2, so it's -2 equals 1/x minus 4 minus 2. So that's how you find out that this guy doesn't make any sense here. When you put -2, this one would not make any sense. It's a false statement, which means you also have an asymptote at that location, which is -2. Okay, so that's the graph of basically the graph of the rational function. Let's do one more example. Obviously here there's two asymptotes again. One of them at y equals -2. Horizontal is y equals -2, and vertical is x equals 4. Let's do another one. And this one we're going to graph y equals. We've got 1/x minus 3 plus 2. 1/x minus 3 plus 2. All right. So first thing first, you got to know what's h. Can somebody tell me what's the h here? Am I moving left or right or up and down? And this here. X minus 3. Am I moving up, down, left, or right? In this case, I'm actually going to move to the right 3 units. And I'm going to move up 2 units. So if you guys remember, instead of 0, 0 being the focal point, this one is going to be 3 and 2. So I'm here somewhere. Okay, what about my asymptotes? Well, look again at exactly 3, you will have an asymptote, a vertical asymptote. So I'm going to come here and choose the vertical asymptote. That's 3. Just like that. How about the horizontal asymptote, sideways? It's going to be exactly at y equals 2. So this tells you, and the k tells you the y asymptote, which is at 2. So I have also a horizontal asymptote at 2. This is y equals 2. And this is x equals 3. These are the guidelines for, these are outlines and guidelines for graphing. So basically I'm going to end up with a curve that looks like this. And another curve that looks like this on this side of that line. Oops. On this side of the line of the asymptote, just like that. These two curves are going to be your graphs, and this focal point is going to be 3, 2. This is the K, up and down. This is the H, left and right. Okay, it's always the opposite. Okay. Any questions thus far? Any questions on the rational function and how we graph rational functions? Any questions on asymptotes? So remember, when you graph rational functions, make sure that you take care of the asymptotes first. These serve as your guidelines for the graph. You should not cross these lines. You should come so close to these orange lines, but you can't cross them. That's why we call them asymptotes. So here we have, I'm going to put these down, asymptotes.